All right, peep this intro. You can't even see my face, but now you can. Pretty interesting. Not really, pretty fucking stupid, but what I got today is pretty cool. Something that has been in the works for about 3 months right now, maybe even a little bit longer. But if you've seen it in my videos, it kind of always sneaks in. But on my wall over here, you can see that I have a BCI headset. I also have a dead boosted battery and a boatload of other wires and stuff. But this bad boy right here is my I don't know, pride and joy. I don't know what the correct terminology is for it, but just something that I have been really enjoying and building with. So something that has interested me throughout basically my whole entire life is the idea of being able to read my brain, and then also like the idea of, you know, trying to transcend consciousness. But that's kind of like, or transcend life basically. So like, you know, taking whatever consciousness is, if it is neurons in your brain or if it's something else, and then like being able to move it to a different body so that, like, you know, we could live forever. Or if like somebody got some sort of like super shitty disease, you can just like basically be like bloop into a new body and then you'd be solid. But I'm digressing. So the point of today's video is actually we're going to be finally able to train a neural network. Basically, AI is, you know, to the average person, it's new. It's like, whoa, ChatGPT, this, I can generate images, the new Veo 3 videos. It's like, oh man, you know, it's coming for my job, this, that, and the other. Which, I mean, all is true except for the fact that it's new. It's old. AI has been around since about 1943 or so when it all started. There were two main researchers that were doing most of the research there. And basically their goal was to create some sort of mathematical model of a biological neuron. So again, it all kind of stems from the brain. The goal has always been to basically, you know, take human intelligence and implant it into computers, but it's kind of hard when, you know, computers are silicon and our brains are just, you know, a boatload of meat up there. It wasn't until about 1958, I believe, where the perceptron was the first neural network model that could actually learn patterns. Back then, it was what people thought would lead to intelligent machines. So things that, you know, we see in movies, or even what, you know, you and I would believe AI to be today, kind of like, oh, it's, you know, it's so futuristic, it can predict, or it can speak to me, but really it's just predicting the next token. So it's basically just statistics. And then after that, we had what they called the AI winter. Basically, nothing happened of significance from about 1968 or 69, I believe, all the way until about the 1980s or so. Because in 1969, Marvin Minsky, he basically crushed the idea of the perceptron. Basically, he proved that it couldn't solve complex problems or even simple problems like an XOR gate. And so basically funding dried up. Everybody was like, AI is stupid. There's no real point in, you know, trying to invest in this. It just isn't possible with today's technology. Then kind of fast forward to about the late 80s, early 90s, where basically they were looking at a method to basically train multi-layer neural networks. And then basically they started outperforming the old methods in things like handwriting recognition, small pattern recognition, math, and small statistics. That kept going, people kept moving on that, and it kept getting bigger and bigger until about the early 2010s in 2012. In 2012, we had basically the first big game changer, and that was a neural net called AlexNet, which it crushed a few of the baseline challenges such as ImageNet and beating all traditional computer vision models. So that was kind of like the birth of the deep learning model, which is basically, snowball it forward, how we got to today. So there's a ton of really, really cool like Stanford experiments from the self-driving cars, mapping out and figuring out maps, and just a ton of information. So if you're really interested into it, there's a ton of information out there on YouTube. So you can go and check it out, but I won't bore us too much more with the history of AI. But basically, neural networks took off. That's where we started to get GPTs and Dollies and DeepMind and DeepSeek and now Google and everybody else. But basically, that's what we are and how we got to where we are today. Feel like freaking Dr. Xavier with this bad boy on, or maybe even Magneto. The goal of this video was to train a neural network on my own brain, my own thoughts, so on and so forth. So that took a while. It took a while for me to code it all up in Python. It took a while for me to figure it all out. Even with AI's help, it was definitely still a struggle. But basically, yeah, for those that don't know, I guess this is an OpenBCI headset. So it uses this board right here, which plugs in via USB to my computer. I then plug it in. It is now looking for a Bluetooth connection, which if I struggle with my fat fingers to find the thingy, turn this bad boy on. So yeah, without further ado, it is a little bit boring. I'll probably speed up the training, but I'll maybe show some highlights because it also does take some time. It takes about 30 minutes to train. So I actually got some dinner right here and I'm just gonna eat and train because you have to be in a quiet environment. Because it's tough. Basically, I mean, my neurons are continuously firing in my brain and there's a shitload of them. So to try and get good readings is always quite hard. But yeah, let's get to it. All right, so switching over the camera angle a little bit, you now can see my screen and see the kind of crappy UI that I've made. The live neural network is probably what I'm most proud of, but the rest of it is all just kind of meh, it's all kind of thrown around. But that's because I'm using Python and GUI, it's not really the top priority at the moment, but the data is. So that's what I'm here to display is how I am going to train the neural network on my brain. So we have 3 test cases. We have the left hand, the right hand, and then just plain resting. And so the way I go through it is basically pretty boring for you, the viewer. I'm probably going to fast forward. You'll just see like a speed time lapse of the whole thing because I'm literally just going to sit here with my eyes closed, maybe a little bit open, and I just have to like vividly think about what I'm trying to do. So like for the left hand and the right hand, you'll see some cues up on the top, but basically I just vividly think about like squeezing my hand, but I can't squeeze it. It's only supposed to happen up here in the brain. So I'm like squeezing the hand. It's actually quite challenging to kind of do because you do it without thinking, for most of your life. So it's always a bit interesting and hard to try and do it at the beginning. And sometimes the accuracy shows that. But yeah, without further ado, we'll get into it. It'll probably take me about 30 minutes because of how long it takes to train the whole model. But yeah, well, that's what I'm going to do. So here's a quick time lapse of me training the model. I guess first I can also show this and kind of like what I'm doing. I click start training down here in the bottom left and it'll open up the port connection. I'm using my COM3 port, so I'm connecting it here. It is then going over, connecting, and then yeah, now I have 10 seconds left before we go. So she cried diamonds. I'm crying diamonds. We're able to do left and right hand and rest with 17. So total training shape, we did pretty well. We got 70.1% on training accuracy, which is pretty good. And then, yeah, we were able to save the training model. All right, so I actually was a little bit confused because I thought it was an issue, or maybe I just need to restart the GUI. Yeah, excuse the hair whenever I wear this thing, but it's actually an issue with the board. The board on the back of the headset, basically it has a little lithium-ion battery pack, and that's why also in the middle we stopped at 17 samples, because this bad boy actually died. So we need to charge it, and then we'll be back. So, kind of a weird cut. It's been about a week now, maybe even a little bit longer actually, of just me kind of grinding away on this. So, as you saw, basically, I was able to train a model, and it's actually still the model that I am using. Its accuracy, I believe, was around 70.1% or so, which is really, really good for the training accuracy. So, I'm still using it. I haven't trained any new ones. I've trained some quick training models. As you can see, I will boot up the GUI here. It also has some new changes to it, a little bit cleaner, a little bit different from when you last saw it. But let me go ahead and start the recording here. So you guys should be able to see my screen now. But yeah, basically I still have the live neural network. I have the training progress down below. There's a new button. It's the quick training button. Basically I got tired of, before you saw that one run, basically there were multiple instances where I'd go to train a model and either the data would get corrupted, I would mess something up in my code, and then it would corrupt the data, so on and so forth. And instead of making copies like a smart person would, I was an idiot and just basically kept overwriting and overwriting. And yeah, I would just keep corrupting the data, and I got tired of sitting around for hours training and just trying to think really hard. So I made a quick train button, which just does 5 quick samples to kind of get a baseline. And then from there, we have the new live channels. We have the actual confidence and the live mind reading. And then we still have the power bands down at the bottom. One of the things that took so long as well is I actually learned that around 20% of the population really struggles with visualizing their motor skills, or not like the actual motor skills themselves, but like if you say like, okay, envision clenching your right hand, it's not necessarily a huge spike in your brain waves. Like there won't be such a big difference to where you can actually analyze the pattern. And so it gets quite challenging for that 20%. I believe I'm on the edge. So for like the start of my training, it was really hard to see. Like I was really struggling with like left hand closed, right hand closed, and then just plain nothing. You could kind of see a little bit of a difference within the data, and then for some of them you couldn't. So it was making the training data like really iffy. So basically the only way to get better at it is to keep training. So I trained and trained and trained, and then basically yeah, that's led us to the point where we are at now with that same model still, but now my capability of envisioning something squeezing in the right hand or something squeezing in the left hand is a lot better. And so it picks it up a lot better. So that was a lot to say, but without further ado, I'm going to go ahead and go through with the demo here. It's going to be, to me, it's super, super cool. So, but I do have to focus. So you're going to see me like really focus in, really go through it, really imagine and envision. Basically what I do is I envision squeezing a ball, like a stress ball or something, in my left hand. And then I'll envision doing it in my right hand. And then I'll envision doing like a resting state. And so it will work. You'll see me probably get quite excited, and then it might go a little bit haywire, because once you get excited and if you start moving your head, you know, the brain waves, and it just messes stuff up, to put it simplest. Yeah, without further ado, let me click the viral demo button. We should start to see the neural network go live. The bands are live. Okay, and now it's kind of all over the place. So I'm gonna hone in, and you'll kind of know when I'm thinking about something, because I'll really be surprised. Okay, I'm right hand. Okay, I'm nothing. I'm left hand. Okay, I'm nothing. I'm nothing. Whew. Okay, that was cool. I don't know. So like right now when I'm talking, this is where I really my research and expertise, not that I'm an expert in any form, I'm a complete novice, but really goes downhill. Because like right now, I would expect it would kind of be in rest, but maybe because I'm moving my hands and moving my head, it thinks sometimes it's a left hand or a right hand. Most of the time, as you're seeing, it is pretty close to rest, but I don't know, still kind of interesting. Okay, let's try and jump back in and see what we can get here. Okay, I'm right hand squeezed. Ooh, okay. All right, I'm going right hand. Nice. Oh, that was so cool. Oh, that was great. Oh, see, like right there. The delay, it's a little bit, but oh, that was sweet. Straight from rest to right hand, really envisioned it in my mind, and it went like, I don't know what the exact percentage, but it was like maybe 40, 60, and then even 80. So I was really, really envisioning it in my brain, and that was really, really cool. But yeah, that basically wraps up this video. I plan to do a lot more with this. For those, one of the things that I thought would be super cool, but it's probably really, really far down the line, is I am working on some robotic hands. And so this is a finger and index. I think this is an index finger. It'll actually bend and move with servos. So like it actually has tendons. So I'm hopeful that down the line I can basically train a model for me to move my fingers and then not move my fingers at all and have the robot hand move. I think that would be super, super cool. The problem is I work full time. So, you know, I don't know when that video will be out. Hopefully by end of the year. I know that's kind of a crazy statement to say, but it takes a very, very long time to build all of these things. All of the apps that I do, all of the just crazy things I'm trying to do. So I apologize for that, but this is by far my favorite video that I think I've ever made. Just the amount of work that I've put into building this shitty UI and the headset and learning and trying to figure out everything with neural networks to how EEGs work to, you know, all the difference between the actual power bands. What's this doing? What are these channels? Because each one of these is a different channel. Which do they actually, because they all map to different cortexes in your brain. Some are visual, some are motor, some are functioning, some are cognitive thinking. There's just so much to this that, I mean, I'm not sure how much is interesting on YouTube. I'm going to try and, you know, showcase as much information as I can to you guys without making the video too boring and like a lecture. But this is something that I find super, super fascinating. And yeah, look out for more projects in the future on this. I definitely think I will be doing something super cool with this in the future. And if you guys have any recommendations, any ideas, or anything like that, yeah, please let me know in the comments below. So yeah, it's been your boy, Tom, and I'll see y'all at the top. Peace.